good introduction, actually. I wrote it myself. So I will skip about me slide later on. And since we are before lunch break, thank you very much for coming. So just if I will overrun the time, once again, thank you. There is a contact to me on this slide, and there is also a source code put on the GitHub. So if you would like to verify it, that's the place where you can look for it. So I will start from Maven because obviously it's more popular tool, and I will reuse the same jokes as I had. So it's a very common term to be found on the internet that I hate Maven. So as you can see, Google already indexed 12,000 replies such this, and in terms of OSGi, it's just 8, meaning that OSGi is fairly more accepted as a solution and have less opponents. But if we go a little bit more, there are also some statements that OSGi is a niche, because facing the truth, maybe the amount of haters is so low because the usage footprint is also not that high. And I went today morning to Google Trends to see how it looks alike, compared all the tools, and the yellow line is a Maven. The red one is a Spring Boot, and green one, I can't remember. Oh, this is Gradle, and the blue one is the OSGi. So as you can see, these tools are moving over the time. Maven searches, amount of the problems with Maven increases, amount of problems with OSGi decreases, but also it can be seen as the market adoption is, well, not progressing that fast. And at the same time, you can find the spin of the Spring Boot, which goes quite high, and maybe there are some ways so we could stick ourselves a little bit to the mainstream. So as Mark introduced me, I will just say that I work for some companies, and I used to travel and train people how to integrate the software. And I had 5 days to do a working proof of concept, not to introduce the OSGi, but build a proof of concept on top of OSGi platform. So I couldn't really take too much time to introduce people into the OSGi. I had to use the tools which they were used to use and teach them how to use it in the productive way, so to do not raise too much troubles. So the world outside, it looks like this. This is a community survey hosted by Snike, and it's based on 10,000 replies. So as you can see, this is the tool usage, and the Eclipse IDE is 38%, and the IntelliJ is 45%. So I believe this doesn't sum to the 100%, maybe it does, but you can see that the usage of the IntelliJ is not that low. And since OSGi was perceived for some reason as the Eclipse friendly, we need also to take in consideration the other tools. The NetBeans is also used, and there are some new arising tools like Visual Studio Code. And in terms of build tools, 60% of guys said they used or will use Maven. So a good integration with Maven, which guys from the BND tools are working, is really a good approach because it allows us to stick with the mainstream. And if we talk about artifact repositories, the most popular are Nexus and Artifactory, and those two somehow do not advertise themselves as OSGi repositories. Those are typically Maven repos. So you deploy Maven artifacts, and if you pay extra to the Sonatype, you can have the professional P2 and OBR repository plugins. But out of the box, these tools are meant as a Maven repos. So those are for distributing the stuff. And you most probably use, or if you write the Java code, you use actually Maven Central, right? So this is the distribution method. And if we are talking about the tools, there is JUnit, Mockito, Selenium. Of course, Selenium is not our thing under the OSGi because it's a browser thingy, but there are some things like Cucumber, PowerMock, and so on. So the first two are fairly supported on the OSGi platform. You can run them, but there is a bit of unclearness how to run these things because there are different approaches. And in terms of runtimes, we have a Tomcat and some application servers. So my point is that on the next slide, the OSGi as is not classified as a runtime. Maybe because it's a tool, not an entire solution. So Tomcat is a runtime, and OSGi is a framework. So this is a major difference. There are some servers which are supporting the OSGi as a development model, but it's not a primary thing. If you think about the WebSphere or Oracle application servers or even JBoss, they have a different development mode, and they promote the WAR ER and their now microprofile stuff. And we also face some communication troubles. If you work with the higher management, you have to pay attention what you say. For example, if you say that there is a problem running OSGi, or there is a problem running library X under the OSGi, all what the manager will remember is problem OSGi. So, and if he is not convinced fully, then he will keep repeating that, and this will wave over the organization, repeating that OSGi is a problem, because those are 2 key points, and no one will remember the library, because the library will change over the time, but OSGi and problem will stand. So if you are working in the bigger organization, which software is not the primary thing, quite fast you can run into discussions, shall we even use the OSGi? So there is also a problem finding the people knowing the OSGi, because it's not that popular. And my thing is that if we will look a bit closer to the Maven, maybe there is a way to promote the good approach from Maven through the OSGi and then make these things matching together. So I will run really quickly over the Maven. So you most likely use it, and you know that it's a build tool which allows you to compile stuff and do lots of the stuff like running the tests and so on. But it's also a tool which was meant to promote convention over configuration. So if you don't have to configure a thing, do not. You do not need to point where are the sources. There is a convention, and sources should be there. Test sources should be there, and so on. It's also a repository client which is able to fetch things and manages dependencies, which is a hard thing, as we know. And it's also under the hood a quite pluggable machine. It supports some layering in terms of the configuration, so you can have different levels, and the CI server can, for example, override project settings, which is useful for running Jenkins and stuff. And there is an inheritance which is supported, so you can have there is a super POM which is always included. It's an implicit one. So each and every Maven project inherits from it. But then you can have organization POM which bounds, for example, versions, defines some of the boundaries, and then projects which are inheriting from it and going into these boundaries. So you can use Maven actually to create limits via the dependency management. You cannot actually ban dependencies, but you can at least say if this is the dependency, then it must be in this version, which is useful for doing the company-wide projects, which have to cross sometimes the boundaries. And the inheritance allows you to promote the dependency management, dependencies itself, and also some plugins and resources. So coming back for a moment to the conversion over the configuration. So beside this basic one about the sources, there is also reasoning where the outputs should be put. So they are also removed automatically when you want. And the very important thing about the Maven is that it is not task-based. It's based on the phases. So plugins are always hooking into the phases, which are meant to be executed in the chain. So it's a big change from the AND, Gradle alike builds, which are task-based. So you can link the task and so on. And Maven says, okay, those are phases, and if you want your plugin to be executed, you just need to declare into which phase you are aiming. You can also override it in the plugin configuration. So for example, you might use the same plugin for doing different things if you want to override the configuration. But the defaults and convention really is dependent on the plugin. Each and every plugin developer can decide. In terms of repository client, you know the group ID, artifact ID, so I will skip it because everyone uses that already. But the key point is that the central Maven repository is enabled by default. If your thing is deployed there, anyone actually can use it without any configuration, any overhead. And the dependency management, which is very important for each and every organization, is a key takeaway, which is somehow matching also what OSGi is trying to do. So Maven, compared to OSGi, recognizes scopes of the dependency. So there is a compile, runtime, provided, and test. And for example, that's the issue with the PDE build. You have no scope in the manifest, right? There is no such thing. You declare your runtime dependencies. Maybe if someone wants, then you can add attributes in the Maven, in the manifest. But Maven as a build tool allows you to separate the dependencies which are used for compilation and which are used for tests. And this also impacts which one are promoted as a transient dependencies. And let's go exactly to these transient dependencies. So in Maven, if you declare dependency on something, then you are also including the dependencies of that dependency. So if you want to compile against, I don't know, maybe Guava, and Guava have a side dependencies, then you automatically get this into your class path, which is quite convenient and solve lots of the troubles which Ant couldn't. But at the same time, you can run into the troubles that two dependencies are using different versions of Guava. That's a common example. It became actually a new problem, how to marry the Guava between different projects. So with dependency management, you can say, I force my project to use this version of Guava, right? So this, by such basic thing, you can define your target platform saying, okay, we stick with this version. And of course, it's a problem if you have dependencies which are relying on the new features, because at the runtime, it might be still a problem. But this problem is addressed already by the OSGi. So one more thing about promoting this dependency management. So one of the new things introduced in Maven 3 something is possibility to import dependency management section. So here is the whole trick. You can include another POM and say, okay, give me your dependency management. So I do not repeat it. I do not need to define placeholders. I just stick with this platform. So if you are working on the project which is meant to run and compiled against certain versions, that's how you can do it. And it's native way how you can do it in the Maven, just a couple of lines, sadly in the XML. So in terms of the pluggability of the Maven, quickly, it's based on the class path scanning, so it's not that advanced, but it allows you to customize very, very specific things. For example, a version resolution. Most of you probably didn't know it, but there is a support for version ranges, and you can also override the logic how Maven resolves it. So you can say that version. So there is a slightly different semantics in versioning in the Maven. For example, 2.0.0 snapshot is not 2.0.0 yet. So that's the main thing. If you have a snapshot classifier, it means it's not yet released. It means it's not yet 2.0. For example, in the OSGi, 2.0.0 and this snapshot is just a classifier or qualifier, sorry. So it doesn't really matter. It's 2.0.0 because the major part of the version counts. And I made some experiment 2 years ago, and it's possible to customize that and plug the OSGi version ranges and just strip the Maven logic out of it. So you can do version ranges in the Maven as well in the same way as you do with OSGi. And then let's come to the commonalities. This is a very broad comparison. So a primary build unit for OSGi is a bundle because that's what we actually deploy. I know that dependency unit is a package and then requirement and capability. For Maven, it's much more granular. You depend on the whole jar. It doesn't support such generic concept as requirement and capabilities. And in terms of the platform definition, I already said that for PDE, for example, there is a target platform definition, but with the Maven, you can use Maven itself to push it through. And there is a support for version ranges and different support for repository formats. But those two things, the repositories can be used, as the team already shown with BND, and wrote. And I would like to go to the project organization for a moment. And why? Because systems are like onions, to quote Shrek. Even if you do a thing which is fairly small, it will grow over the time. And most of the guys outside know how to do layers. They speak layers. Every bigger organization do some layered systems. Even if we have the microservices, which promotes, or the new microservices promotes to put everything together, there is still some reasonability to separate the things and the interfaces. And that's the part where you can start talking to people in the terms which they knew without introducing yet OSGi terminology. So you tell to them, let's separate the layers, and then as a second topic you can tell them, okay, this is a consumer and provider relationship in the OSGi. So as I said, each bigger system has some things: the domain model, persistence, some communication. We don't live in the cellar, so we have to talk to outside world. And many, actually, each and every project have many of these relationships. The more complicated project is, the more of those it has. So the key thing is that if we start talking to guys and tell them, if you structure your project properly, not even yet mentioning the OSGi, it will be easier to maintain. And the maintainability of big project is a problem. So let's talk about the problems and how to solve them, and do not talk too much about OSGi maybe, because most of OSGi projects is properly structured, so it enforces it, and some of Maven projects are also properly structured. I would say that many of them are not, but some are fine and could be used as an example. For example, have you used the faster XML Jackson parser in the past? I guess some of you probably use it. And it generates OSGi metadata since ever, and it works quite fine. So it could be used as an example, a project which is used in the regular development, it is used in the OSGi, and there are no troubles, no problems with interoperability of those two. And this is a basic project structure which I would like to show, which reflects more or less the Maven structuring with some examples, some exceptions. For example, there is a split of DAO API and core and web API and core. And why so? And some of the Maven guys have problem picking it up, but the main thing is dependency management. So you do not plug too many dependencies into the API modules, and then when it comes to testing, you do not have implementation dependencies, and it also forces the younger programmers to use mocking upfront, to do not try, for example, to embed the database, because there is no actual implementation of the persistence, so you have to mock it. So that's one of the things which I implemented in the project. I'm going to show it in a moment. And then the manifest in this structure is just another resource. There is no reason to do not make it, and there is no problem to make it, because things are separated also from the Maven point of view. And this is how it could be generated with Maven bundle plugin. And the BND have its own plugin, and both are based on the BND lib. That's the key point. And the major differences are the defaults, the convention which is promoted by the plugin. The BND, if I remember, or if I recap properly, the talks I had, doesn't export anything by default. And Maven bundle plugin exports everything, but not internal and impl packages, because the common convention is that implementation goes into the impl package if you do the Java. There are some guys which are using the internal, but quite often the impl is the word to say, okay, that's where actual code is sitting. So this everything is computed from Maven POM, and I guess BND does it the same way. And now, once we are on the Maven, and one of the missing pieces is you do the OSGi, right? And you want to deploy your stuff. And how do you do it? You can export it from the PDE, you can create a assembly or whatever, but how you actually do it? And here the Karaf comes in, which tries to have a runtime. For example, you download the Tomcat, you can run it. You download Karaf, you can run it, you can see that it works, and that also can be an artifact to deliver. Guys then can see that there is some runtime which they can use, because one of the models is that you can assemble within the OSGi, you can assemble your runtime, but the actual problem is that there is a certain load, certain work which you have to put in it and maintain it and so on. So over the time, it creates a maintainability on the project. So Karaf tries to address some of those and add some of the additions, but all of them are based on OSGi. Actually, Karaf is nothing but OSGi plus some extra things like logging service enabled by default, which also allows you to stick with SLF4J. So if your library uses SLF4J, silently it goes through the log service. So there is support for running the regular libraries without bothering too much on the OSGi part. And at the same time, the Karaf community tries to support the common developer modes like var-based deployments and so on. So if someone used to work with web application development within the Java, it can try to run Karaf and see if it works. So this previous slide, you've seen it probably dozens of times if you heard about Karaf. But under the hood, there are few things like pax URL, which is a nice thing because by default, OSGi framework supports HTTPS and file locations for your bundles to be installed. And this is a standard set of the URI schemes, which comes from Java platform. And framework adds the bundle prefix, but pax URL actually adds some additional. And one of the most interesting ones is wrap. So you have a non-OSGi bundle, jar, and you want to twist it into the OSGi bundle. And you can do it with the wrap URL. So you just specify the URL to your bundle, to your future bundle, say, okay, this is the location. And then after the question mark or $, you can put BND instructions, and it will do wrapping on the fly. You do not need to repackage, and do all this maintenance on the dependency. You can wrap it on the fly. And there is also some support for class path stuff, and also the most important one, which I wanted to point out, Maven. So this MVN allows you to stick with Maven repositories, and then by specifying URL like install MVN group ID / artifact ID, you will go to the Maven repositories, to Maven Central, and fetch this thing and install in your runtime. So there is no need to place entire URL. Plus, you can switch the configuration of the pax URL and then use different repos, your internal ones, and use the existing Maven infrastructure. And yeah, this is the syntax for deploying this stuff. And here we are coming to assembling the things together. And this is an example of Karaf feature. It grown over the time. It was a fairly simple mechanism. Now it's slightly more complicated. But you say, what are the features, other features which you depend on, which can be declared by Karaf or other dependencies which you have, and then list bundles, and that's it. But of course, it's a maintenance problem, right? Who would like to write this stuff? No one, actually no one. So for those people who wants to do it quickly, we have support via Maven plugins. I can show you, for example, here. That's the feature definition, which has no bundles attached. They will be added during the build time from the Maven dependency. So from your Maven dependency tree, there is a population made, or the extension of this feature made. So there are just high-level dependencies which you require in the runtime, which Maven might not understand, and then the bundles are appended dynamically. And I know it's not the most reliable way of doing things, but that's the easiest way to do it at the first step, right? So you can get all your class path elements and turn it into the Karaf feature and deploy, ship into the OSGi framework. Notice that I'm using IntelliJ, so it works, thanks to usage of Maven, it works with everything. There are certain problems you cannot have this nice run and hot swap stuff, but there are ways to do it as well. So for each and every more advanced Java programmer, it will not represent a big issue, because after all, most of us who did the Tomcat-based development had it aside and were deploying it somehow, because the tool support for, I know that Tomcat can be embedded in the IDE, but it's quite bumpy road, and sometimes both IDEs, regardless if it's IntelliJ or Eclipse, gets crazy. And now let's come back to testing, because if you have a real system, you have to test. I mean, there is no way to avoid it, right? And the PDE model, for example, was using the OSGi then to run the unit and then run the test. But the world outside uses a different approach, which is wrapping the application server here in this place. So I put OSGi as an example. That's your runtime, but this could be, for example, a Tomcat, a JEE, whatever. A common scenario is to run JEE as an embedded test. So the JUnit is a main driver, and then the tests are somehow plugged into this whole thing. And I want to show you how to do it with Maven, and this is actual example how you can run it, right? So there is a run with Pax exam, there is the tests, and as you can see, there are injection points, a lookup of the service, and then some logic. And at the end, the most important part is the configuration. So within the test, you say which runtime you want to test with. So here we have the information. That's the assembly which we are running on, is the EclipseCon project which I made. It could be a regular Felix framework, depending on the configuration. It could be also the plain vanilla Cara, but because I already embedded my features and my project in this assembly, I run this assembly to do not have troubles with installing bundles and so on. So I have a pre-made runtime which consists my project, and then do a test on top of it. So once I have assembly, I can test and do integration testing. So there are also some additional options, and for example, here you can also place a debug option. So the process which is spin off will be started in the debug mode. So then you can attach your debugger from your IDE to running process and debug and see how it goes. And this actually works. Let me show. Can I run it? Yes, I can. Let's see. Yeah. Okay, it failed because I didn't build it here. So that's the disadvantage I was saying on, right? That not all the things are working smoothly between the IDE and the OSGi. So now I'm building this is the assembly building. It takes a bit, and yeah, and this is the test execution from the Maven side. The main problem which was there is the lack of the information of the dependencies. So just not to drive too much into the details, the actual plugin, the JUnit thing which was used there says version as in project, and this version as is project has to be specified somewhere in the project resources. So there is a plugin, Maven plugin, which generates some information, and then this test inside the IDE can be run. So so here it did run. So most likely it's useful when your test fails within the Maven, you can always fall back to the IDE and run your test. As you can see, it's spinning on. So we have to give it a second. This computer is way too old. Yeah, one test passed, and the second one should also pass. So it embeds the OSGi framework, the runtime in the separate project, in a separate process, and yeah, that's how it's made, right? But on the highest level, if you look at it, it's just a JUnit integration test. So let's go back to my slides. Glad it worked. So a comparison would be, there is Arquillian. If any of you have ever worked with JBoss stuff, they have their own tool. The tool which I used is called Pax Exam. And there is also a very nice project called Pax Tiny Bundles, which allows you to wrap the class path resources which you have, and inside your test, create a test bundles and deploy these small bundles as part of your testings. Because we are running close, those are containers, this is example test. And one last thing which I wanted to mention, there is also a way to emulate the framework without running the framework itself with Felix Connect. So it keeps the basic semantics of the framework, like service lookups and bundle context, without being too complex. So for very small unit testing, it's actually quite okay. I managed also to run SCR on top of it. So it is emulating. It's not that I wouldn't run the whole solution on it, but for unit testing, it's just perfect. And it takes just few lines of code to create a bundle context to spin off your framework. And this is the most important part. You say which things from the class path you want to include. So here is a class path scanner, and this is a mask which says pretty much everything which has a bundle symbolic name, but OSGi artifacts. And then you have your small unit tests, which can use service lookups, and you can test the whiteboard pattern, for example, easily, right? Because the extender pattern is going to work with it. And one of the big pities is that the JUnit 5 support doesn't exist. It doesn't want even to support OSGi so far. But one of the nicest things is that you can run, for example, with this approach, the asset J, which is much more convenient to write assertions than Hamcrust, right, or how it's spelled. I believe that the Hamcrust should be punished and killed and removed from Maven repos because it is so difficult to read the tests. Okay, any questions? We have 2 minutes. Or 0, because Mike is approaching. If you have any questions, you can bug me. There is also Christian, who works on Karaf, who had previous presentations, so both of us can talk about this topic.
So the one thing I'd just like to say, and I know Lukasz mentioned it a few times, is about IntelliJ and the fact that the support for OSGi is not good in IntelliJ. I'd just like to make it known that that's not because